In this lesson, we're going to learn how to write the selection sort, which is one of the easiest of the sorting algorithms to create, but it's also one of the most inefficient. Let's watch an animation of the selection sort as it goes through its processes. The way the selection sort works is it looks through a list of elements for the smallest value, and when it finds it, it places it at the first position. Then it finds the second smallest value and puts it in the second position, and so on. So notice how it's going to find 6, then 7. Let's watch it again. Here it's going to look for 0 and place it at the beginning. Now it's going to find 1 and place it next. The 2 is already in position. Now it's going to find the 3. Now it finds the 4, and so on. So that's how the selection sort works. Now let's look at how to write the code for that sort. We'll need the ctime and standard lib headers, so I've included those already. So the first thing I want to do is write a utility function display so that we can display the results of our sorting. So let me do that first. Take just a moment here. So all we're doing in display is simply providing a means of displaying the contents of an array at any time. Now we're ready to write the selection sort. Let's move down. We'll call our function selection sort. It will take 2 parameters, an array, and the size of the array. We need 2 variables, first and temp. The first thing we do is we start an outer loop that begins at the end of the array. Initialize first to 0. Then we write a second loop that begins at position 1. It continues until we get to the current value of I. And then it compares its value in the array to the value stored at first, which, as you noticed, is position 0 to start with. And if a value is greater than the value at first, then we assign j to first. And then we perform a swap. And that's it for the function, actually. So now what we'll do is, let's try it with some code. We'll keep our array sizes small. We'll only do it for 10. Now let's seed a random number generator. Let's initialize the array. Now we'll generate a random number and assign it to the array position. And then we'll display it as we go. Then we'll add a new line at the end. Then we'll call our selection sort with the numbers array and its size. And then we'll display it. And we could have used display actually after this loop instead of the cout, but this will be fine to do it like so. Alright, so let's build and run the program. So there's our initial array. Notice I left out the space, which is no big deal. Let's just fix it so we can run it again. There we go. So let's build and run again. So there's our selection sort. That was our array to begin with. And then here's our array after the selection sort is run, and you'll see that it's in sorted order. If we want to see how it looks as we're going through the process, we can put a display call right after the inner loop in the sort itself, like so. So now let's build and run the project again. And here we can watch the process as it works through. There we see that we started out with 32, 48, 39, 55, and so on, and then ended up with a sorted array. So that's how we write the selection sort function. And now we're ready to move to the next lesson where we're going to see how to write the insertion sort function, which is another simple sort that's not very efficient for large arrays, but is very easy to implement. And we'll see how to do that in the next lesson.